Hi everybody, I hope you can hear me okay. Today we're going to talk about SI units. This is also known as the metric system. And there will be times where you'll need to pause this video and write down the slides. I will also upload the slides to Google Classroom, so you do have both of those options, but here we go. So SI units, you've probably heard of these. These are a set of units used to measure mass, length, time, and volume, and more, things like watts and newtons, pascals, but we focus on these in the 8th grade. Okay, I think you've seen this before if you've heard of a kilogram or a kilometer, or kilometer, however you say it, or a centimeter, then you have heard of SI units. Why do we use them if they're so different? Why is it so hard? A lot of people think that the metric system is really hard. It's actually way easier than the American system. So why do we use them? Well, scientists use it worldwide, and so we need to be able to communicate using the same units. Okay, that's the basic reason. Also, it's super easy to convert or change units because it is based on tens. Unlike our system, which has something like 2.54 centimeters in an inch, and so there are way crazy things like that. How many feet are in a mile? 5,280. How many inches in a foot? 12. There are so many different numbers you have to work with, whereas with the SI system, all you have to do, if you can do this or you can do this, then you can change units in the metric system. Okay, so here are our basic units of measurement. So if you want to pause me here and write down this table, it would probably benefit you. So like I said, we're focusing on these 4 things: length, mass, volume, both liquid volume and solid volume, and then time. So our basic unit for length is the meter, and of course I've talked about how you can abbreviate things in science class. We like to write everything down in code, right? Because it saves us time. So the unit for meters is a simple lowercase m. Now you do have to pay attention to uppercase and lowercase. That will become important here in a minute. For mass, the amount of matter in an object. This is kind of like weight, but not really. Okay, and we'll get to that later in the year. But the basic unit is a gram, and the symbol is a little g. Okay. Volume for liquid. Liquid volume, so a liter of Pepsi. Or a liter of water, okay, any type of liquid. We symbolize that with a lowercase l or a capital L, and here's why. A lowercase l in printing can be confusing. It looks like a 1. It could also look like an I. So I always write mine with a cursive L. The volume of a solid, so the unit we use is cubic centimeters to measure volume. I think you've probably seen this before. You could also do cubic meters or cubic kilometers, actually. And now this is the amount of space an object takes up, okay? And lastly, time, seconds. The symbol is S. We most often are splitting seconds into much smaller units. So I'm sure you've heard of a microsecond or a millisecond. And so we're going to learn how to note those here today. Okay, so these units, I strongly recommend you copy this table down or even print this slide out and paste it into your notebook, because this is where you can put your finger. Let's say I'm asking you to change grams to kilograms. You're going to put your finger on gram, and then what you'll be doing is you'll be moving the decimal however many places it is. So if I've asked you to go from gram to kilogram, okay, that's how many spots to the left. 1, 2, 3 hops, right? So that's what you're going to be doing with your decimal. It will be hopping 1, 2, 3 spots to the left. Okay, now there are many, many combinations I could ask you to do. I could ask you to change a hectogram to a centigram. So you put your finger on hecta, and you have 1, 2, 3, 4 hops to the right. So you'd be moving your decimal that many places to the right on your paper. And don't forget, the base unit in the middle, that is a stop. You can't skip over that one. Okay? That will make more sense as we move on here. Okay, there will be a little slip of paper for people to put this into their notebook, but I wanted to talk through a couple examples here. So you're also going to see the word kilo a lot. Kilo just means 1,000. Okay, it doesn't necessarily mean 1,000 grams, but if I said you had 1,000 grams, okay, that's another way of saying you have 1 kilogram. Okay, sticking with gram, centi. Centi means 100th. Where have you seen this word before? Okay, so 0.01 grams or 1/100th. Okay, that would give you 1 centigram. Or milli. Milli means 1,000th. So number-wise, it would look like this, 0.001 grams. Or we, instead of saying this, because nobody says 1,000th of a gram, they say a milligram. Okay? Hopefully this is clearing things up as we go along. So each prefix has its own symbol, and the base has its own symbol. Okay? So 1,000 grams, it's a kilogram, it's 1 kg. Okay, remember all those codes we talked about? 1,000 liters, we have a kilo for 1,000 and liter for liter. Of course we don't want to write out that big long word, so we write 1 kl. Okay, 10 millimeters, this gets people caught off guard sometimes because the symbol for meter is a little m, which you see here, and the symbol for milli is also a little m. So means millimeters. And lastly, 100 centimeters, we have centi. We abbreviate that with a C, and we have meters, again with the M, 100 cm. I think you've seen this before, but now you're starting to find out what those prefixes actually mean. Okay, so here's some practice, and I hope I can get this to work on video. Keep this piece in mind, okay? This is where in class, I would walk over to my giant board and we would hop through these with our decimal, okay? So have this on hand so you can follow along. Okay, so 114 grams. If there's no decimal given, where is that decimal? Huh? It's going to be right there at the end if it's not given to you, okay? So if we're starting there and I'm asking you to go from grams to kilograms, this is where you need your chart. Well, I know grams is in the middle and kilos way out here, so I'm starting here. 1, 2, 3 hops to the left. So I'm going to go 1, 2, 3 hops to the left. My final answer would be 0.114 kilograms. Okay, moving on. Again, where is the decimal? If it's not written for you, it's at the very end. I have kilograms. I'm asking you to change that into grams. So start on kilo, okay, and how do I get over to grams? I have to move the decimal 1, 2, 3 spots to the right. So 1, 2, 3. You can please draw in your little hops. I do think it helps you to learn it a little bit better. But this is going to give you 2, 3, 4, 5. Now I have to move that decimal. So 1, 2, 3 spots. And then I guess I'd have to go back and put in my commas, don't I? So 2,345,000 grams would make up 2,345 kilograms. Moving on. Our decimal is starting here at the end because it's not given. Milliseconds, how do I change that to seconds? How many seconds is 13 milliseconds? So I start at milli. I know that's over there from practice. And I'm changing it all the way back to a basic second. So 1, 2, 3. Same over here. 1 hop, 2 hops, 3 hops. I'm going to have 0.013 seconds. So keep in mind these amounts, these are equivalent amounts, okay, in the physical world. We are just using different units to describe them. Okay. 1.6 centimeters into kilometers. I don't know why you would change centimeters into kilometers, but here we go. The decimal is given to you in this example. So I'm starting on centi, which I know is right here, and I have to change it to kilometers. So that's going to be 1, 2, 3, 4, 5 hops to the left. 1, 2, 3, 4, 5. So I think it's going to be let's see, 1. 1.6. I believe that is correct. Let's check. If I started it here, 2, 3, 4. Oops, it's one more because I counted wrong. Okay, so 1.6 centimeters is equal to that many kilometers. Okay, this one, there's no decimal given, so we're going to start it at the very end of the number. So right there. Hectograms, I know hecta is right there, and I have to change that to milli. So that's 1, 2, 3, 4, 5 hops to the right. Okay, and so basically I have to add 5 zeros here. 8, 7, 1, 2. And then I can go back and put in my commas. Don't worry so much about the commas. Okay, today I'm not teaching. I'm more so worried that you get the decimal in the right spot. Okay, so I hope that that makes sense. I know that this can be kind of confusing, but another way to think about it is if you are moving to the left, you are dividing by 10 with each hop. So if you go 1 hop to the left, you're dividing by 10. If you go 2 hops, you're dividing by 100. Okay, so don't forget all those math rules. If you're moving to the right, if it's only 1 hop to the right, you're taking it times 10. If it's 2 hops to the right, you're taking it times 100. So again, changing back and forth between kilograms and grams or milliseconds and seconds, it is not that complicated, but this skill will pop up throughout the school year. So I apologize for the long video. Please let me know if you have questions.